Thank you again for all the presenters from the first session. That was really neat. I really had this is some exciting stuff. Well done. You're also young. It's fantastic. Okay, so we are going to continue. The first talk is from Nami Shah. Hello, Nami. It's good to see you again. And Nami's actually going to, she comes to us from Rochester. She's going to present a little bit of results on a new measure of freezing rate. And so I will allow Nami to take it away.
Hi, everyone. I'm Nami. I'm a movement disorder neurologist at the University of Rochester. And so today I'll be talking about some preliminary results from this sub-study. And this was a mixed methods evaluation. And through this evaluation, we were able to find high perceived relevance of a new patient-reported outcome measure for freezing of gait in Parkinson's disease. And this was from the patient's perspective. So I don't have any disclosures to report and just want to thank all the other collaborators on this study, and those are listed on the slide. The sub-study was sponsored by the Michael J. Fox Foundation, so thank you to them as well. All right, so just a little background. As we all know, freezing of gait in Parkinson's disease contributes to progressive disability and has a high potential for injury. And so, especially in that case, it's an important study endpoint to include in clinical trials. And important to that assessment is the patient's perspective of how symptoms like freezing of gait affect their function and quality of life. Unfortunately, though, imprecise definitions of freezing of gait and limited validation of currently available patient-reported outcomes do hinder their clinical trial application. And so a larger international multi-center study, the freezing of gait COA study, developed this new patient-reported outcome measure that we'll call freezing of gait QOL. And so this sub-study actually looked at the perceived relevance of each of the items on this 16-point PRO from the patient's perspective. And the PRO had 16 items or questions on it that covered kind of impact of freezing of gait on 5 key domains: a physical domain, social domain, emotional domain, contextual domain, and a quality of life category. And so you can see kind of what questions they were targeting in those categories on that slide. So in this sub-study, we recruited 41 participants from the parent study. They completed the PRO and then underwent one-on-one interviews actually with myself. These participants were recruited from English-speaking sites in Australia, Canada, Israel, and the USA. Going a little bit more in depth on inclusion criteria, so participants must have completed the parent study. They did have to be diagnosed with Parkinson's disease by a neurologist per MDS guidelines. They had to have access to a personal computer in order to complete the virtual interviews. These were done on Zoom, and they had to have freezing of gait. And so this was defined in this study as an ability to walk 10 meters without aid. They had to be stable on their PD medications for at least 4 weeks prior to enrollment, and they had to score 1 or more point on item 1 of the new freezing of gait questionnaire, which is an existing PRO. And exclusion criteria included, any history of having DBS, any history of having the medical conditions listed on the slide there, and patients had to be able to tolerate being off or delay taking their morning PD medication because that was a requirement of them being in the parent study. So in the interviews, we would spend about 2 hours first creating a symptom map together with the participant. And so I would go through all the experienced symptoms the participants listed, any impacts these symptoms had, and the relationship to freezing of gait if they identified any. And the screen was shared with the participant as this map was created in real time so they could provide feedback and correct any errors. I'll show an example on the next slide. After creating the symptom map together, which was sort of a visual description of their, experience of Parkinson's disease, we then systematically went through each of the 16 PRO items, and I asked participants to evaluate each item in terms of clarity, in terms of sensibility of answer options associated with each item. Did they feel this was generally a useful item in assessing freezing of gait across a population of participants and patients who experience freezing of gait in Parkinson's disease, in their opinion, and whether or not they felt that the item was personally relevant to something they experienced. And so here's an example abbreviated map from an actual participant interview. And you can see that they had freezing of gait and, details were obtained about that. So they identified narrow spaces and turning around as triggers for their freezing of gait. They also identified a lot of other symptoms that they experienced. So after I obtained details about each of these symptoms, they had the option of rank ordering these symptoms within various bothersomeness categories, from most bothersome to not bothersome on a Likert scale. And so this created a detailed symptom map of their experience of Parkinson's disease with a primary focus on freezing of gait. And so after the symptom map was completed, like I said, I would go through each of the PRO items. And so in this example, for instance, you can see how items 2 and 14, where the participant did endorse feeling freezing of gait when they were walking and when they were turning in narrow spaces. They did feel that they experienced this. It was personally relevant. And so this was mapped onto that appropriate place in their map. And so this kind of linked the PRO item to a very most bothersome symptom of theirs. So we thought it was most relevant to the patient. And similarly, in item 4 here, for instance, this participant identified this item they didn't experience this personally. So it was tagged to the not relevant category. So on a Likert scale, this would be 4, and then this would be 0. All right, so just showing a little bit of the demographics of our participant cohort. As you can see here, this was a predominantly white, male, and well-educated group. The average age of participants was about 71, and the average PD disease duration was about 9 years. And then diving deeply into the participant assessment of the PRO, 85% of our participants rated all items as easy to understand. 90% found answer options to be sensible for each of the items. 85% rated all items as useful in general in a freezing of gait population. And so all of these were great. There was some more variance in personal relevance. So even having said that, though, 51% did rate all items as personally relevant. And looking in more detail at this, the figure on the right shows how items were actually ranked in terms of relevance on that Likert scale. And so you can see items related to physical function and ability to multitask were thought to be the most relevant, and items involving self-worth and socialization were thought to be the least relevant. And so overall, there are some limitations to this study. It was a small sample size from English-speaking countries and predominantly white and well-educated group, like I said. So this sample certainly may be missing cultural nuances to the experience of freezing of gait. So doing larger qualitative studies like this in a more diverse population would be beneficial to further validate this PRO. And it does still rely on self-report of freezing of gait from participants. So participants or patients who have significant cognitive impairment and memory issues who may not be able to recall having the freezing of gait or what the actual circumstances of that were, it may be more difficult to use this in those settings. All in all, though, our freezing of gait qual did demonstrate high general relevance and acceptable personal relevance across participants. And the variability in personal relevance likely does reflect heterogeneity in freezing of gait severity and impacts in a progressive condition like Parkinson's. And so overall, our findings do support content validity of the freezing of gait qual across a broad clinical spectrum and, support its use in clinical trials. And again, the last thing I want to highlight is participants really appreciated that this PRO included both future impacts as well as current impacts they may be experiencing, which is why so many of the participants thought the items were generally relevant, even when they didn't personally identify them as relevant. And that's all I have. Thank you so much.
Thank you, Nani. That was fantastic. All right, let me see
Thank
if I
you.
can. Aha. So let's see. I think we've got some good questions here. We have a great question from Dr. Lewis. I was thinking the same thing. Given these participants will have had their fog objectively assessed, Nami, ultimately, will you be able to relate the meaningfulness to actual fog in individuals? And have you thought about how you might do that?
I certainly think that's a great question, and it would be interesting to see if scores on the actual PRO item scale correlates with objective measures of freezing of gait or other measures of disease severity, like MDU, PDRS, etc. I don't have that information just yet, but I do think that would be pretty telling and useful to have as well, and see if that kind of correlates like higher objective scores on video recordings or MDU PDRS, does that correlate with higher scores on the PRO? Or is there more of a disconnect between what is reported on a PRO versus what's seen objectively? So I don't have that data, but I do think that would be very interesting and useful to look at.
Yeah, yeah, I agree. I think that's a really interesting thing to pursue. I think I can tell the audience, that so this is a sub study that NAMI's reporting from an international multi-site study that had very very careful objective assessment of freezing gait, and we do know that some people who think they have freezing didn't end up having freezing, and vice versa. So maybe those data will all come together. Great. Okay, well, thank you, Nami. Our next presenter is Ab Homican from, I believe, Ab, you join us from Dr. Egots Martin's group in Waterloo, yeah?
Sure do. Good afternoon slash evening slash morning, wherever you may be in the world. I'm Ab. I'm a PhD candidate over at the University of Waterloo in Canada. And for the next couple of minutes, I'll be sort of continuing on the mixed methods or the qualitative work, and talk a little bit more about my work looking at emotions, environments, and freezing gait in Parkinson's disease. And when I say environments, I really mean the home environment here. Um, and so I really wanted to look at the home environment because our home is supposed to be our safe space, right? It's a place we find lots of comfort in. We're really familiar with our home spaces. Quite literally, your family is in there, and it's a space where we spend a lot of our time in. But with freezing a gate, we also know that fog is associated with, increased risk of falls, injury, hospitalization, and in conversation of people who have freezing, they'll often describe particular parts of their home as being areas where they feel a lot of anxiety in. So I wanted to explore this interaction between emotions and environments in the home environment, to see how do people with freezing experience their own homes, and potentially ask the question, could freezing warp how those who have freezing view and experience their own homes, differently than people who don't have freezing, let's say. And so the two sort of main research questions driving this study is asking how do freezers emotionally describe being in their particular home environments? And by home environments, I mean, things like your kitchen, your living room, your bedroom, bathroom, etc. From their perspective, which home environments are the most freeze-provoking, and how do these environments that are most freeze-provoking align with their sentiment about these environments, or how they talk about themselves and their regular activities while they're in these home environments? My main approach to this is to look at it from a qualitative perspective, right? Because I was really interested on that patient-informed perspective because they're the ones freezing in their own homes. So to this end, we did a semi-structured interview with both freezers and non-freezers, and asked them general questions about what do they get up to when they're in their home, what gives them difficulty, how do they describe their emotions when they do X, Y, Z task, and how do they describe their emotions when they freeze. In the table there, you can quickly see our demographics. So we had 15 freezers, 5 non-freezers with the age, disease duration, UPDRS, and MoCA scores there. And our main analysis pathway is a combination of thematic and sentiment analysis on their interview responses. So we recorded the audio interviews, transcribed them, and with 3 independent coders, we did a consensus coding design. So everyone would look at the first 5 people or 5 interviews, code them ourselves, and then we all come to a meeting and make sure all of our codes are in consensus. So we all agree with the codes that we've assigned to specific responses. And for sentiment analysis, I used a sort of textbook Vader lexicon and rule-based sentiment analysis. Each word gets some value of positive or negative, and more negative words are used means it's a more negative sentiment speech or structure or paragraph. So the first result I want to share here is relating overall broadly to this environment of relating broadly to freezing and sentiment in the home environment, which is Home environments were described with negative sentiment mostly in the context of freezing rather than general navigation, right? So despite participants saying, I freeze quite a lot in my kitchen and I have these very real fears of freezing and the consequences of freezing, like this participant here who has a real fear of dropping a knife on their foot or falling in the bathroom and hitting their head on something. Their described emotions and negative sentiment really comes about when they're describing their freezing and the consequences of freezing, not their entire environment. When we asked about their kitchen afterwards, they said, well, we like our kitchen. I love my kitchen. I love being there, despite the fact that I freeze here a lot, despite the fact that I feel these very strong negative emotions. So the consequences of freezing and emotion responses were dependent on the environmental context, like dropping a knife, hitting your head on something ceramic, falling on a rough surface, etc. We even went a little bit further and asked about, you know, because you say you experience freezing and all these negative emotions when you're in this environment, does that mean you avoid that environment when you can? And the answer here is also generally no. There wasn't this adoption of avoidant behavior of different specific home environments because of freezing or these negative associations. Where this one participant asks, well, no, I don't really avoid the kitchen, but I do strategize, right? He thinks about why he's going to the kitchen and has a plan of how he's going to get there and make sure he can get done what he wants to get done. So relating to our second research question of, from the patient's perspective, where do they describe a lot of their freezing happening and the sentiment associated? I want to show this really cool association where environments where people report more freezing to be occurring are also environments where most negative sentiments are also expressed. So on the figure on the left here, that's the heat map of the freeze frequency across these environments. So we see the kitchen and the living room really having the most amount of freezing there. And on the right figure, we see the average negative sentiment scores. And here I want to be a little specific. When looking at when they were using negative words, how negative were they is basically what this figure on the right is showing. And here we see this cool association where, increased freezing or increased frequency of freezing is also associated with increased negative sentiment when in the kitchen and when in the living room, right? So there's this really cool interaction or this cool relationship between experiencing lots of negative sentiment and also freezing in that environment as well. So overall, that first initial question I had of, does freezing gate really warp the way freezers experience and view their environment? I think the answer there is kind of not really. They all like their home environment still. They all still feel comfortable in their kitchens and they love their kitchens and their bathrooms and bedrooms, etc. It's just when they freeze, that's when all the negative emotion starts coming up. With that being said, there's still some support for fog-provoking spaces in the home to be associated with increased negative sentiment, but again, only when they talked about it negatively was it more negatively talked about. I know that's a little bit confusing, but that's the area we landed in. And so where I want to take this research in the future is looking at more complex ways of sentiment analysis, looking at transformer models and like some models from Hugging Face and LLM based for sentiment analysis. Looking at possible sex-related differences, right? If I have male and female cohorts, do they describe their home environments and their sentiments in the same way? And the final one is possibly looking at sentiment differences based on subtypes of freezing. If they're a more anxious freezer or a more sensory motor type freezer, does that create any changes in their sentiment? Thank you.
Great, thanks, Ed. That was really, really neat. Let's see if we have a question here. Oh, here we are. Okay. Oh my goodness, bunch of these. Wonderful. So let's see. Simon Lewis says, "How do you control for the proportion of time that people spend in different rooms? You might freeze more somewhere because you spend more time there, but some environments may be more likely to trigger episodes." What do you think?
Yeah, we looked at when this for the sentiment stuff, we looked at the overall like negative sentiment score. So not just uh, how often they describe negative sentiment, but also the overall degree of negative sentiment to it as well is what we measured. So if they only said one or two sentences about feeling really bad, but they were really negative sentiment words, that would go towards sort of the more negative sentiment there. Sorry, did I answer that question? Did I interpret that question correctly? How do you control for the proportion that people spend freezing in different rooms?
I think so. I think you got there. I mean, I think the idea of it's a pretty tough thing that you're embarking on to kind of identify an interaction between this clinical phenomenon and a physical location. And
I guess we also asked, in every environment we did ask, do you freeze in this environment? So in every environment, people did have the opportunity to say, yes, I freeze here more or less here, or less so in the other environment, and describe their freezing in that environment. So we took all the times they would describe freezing in certain environments when given the opportunity to describe freezing in all these different environments to create our sort of freeze frequency scores.
great. Okay. Well, I think really interesting work. I have one. How do you think you're going to link an LLM to this or a transformer? I mean, what do you think? What would that buy you?
Right now, I mean, they're language machines, right? So looking at giving a large context token piece of the entire conversation may give a better sense of the overall sentiment towards a particular environment versus what I did right now with the lexicon base, which is just giving it word after word after word, right? So each word is calculated by itself on its sentiment associated with that particular word. But if I give it a full sentence, like a large language model will be able to use vector embeddings to really give more complex meaning behind words and their mathematical representations than just the simple lexicon-based models.
Neat. Okay. Well, we look forward to see what comes next. All right. Thank you, Ed. Our next speaker is going to be Micah Gorish. She joins us from Catholic University Leuven. And Micah, I think you are ready there. I'm going to give you control of the screen, and then we can go from there. Yeah. Okay.
So hello everyone, my name is Maaike and I will present to you the differences in free living digital mobility outcomes in people with Parkinson's disease with and without freezing of gait. So freezing is episodic, but gait itself is actually a continuous movement. Gait impairments often occur already early in the disease, even without having freezing. And as you saw here on this video, this is a daily freezer whose walking looked pretty normal, and still here we have a freezing episode after which he will again walk normal. So this raises a very important question. What does gait actually look like in between freezing episodes? Do individuals with freezing have normal gait, or is their gait itself also already affected? And most research currently is really focused on measuring and looking what freezing itself is, but less attention is going towards the gait in between two different freezing episodes. Some evidence from lab-based studies already show that freezers have more gait impairments compared to non-freezers, with shorter step length, reduced gait, and more step-to-step variability, which is an important biomarker. But supervised walking trials done in the lab often show goal-directed gait control, so we are measuring patients' best performances instead of their real-world gait. And there are only limited studies that really looked into daily life gait in freezers, and they also show that freezers have more gait variability, reduced stride length, and less smooth gait. But these different studies all have heterogeneous definitions for the use of their mobility outcomes, and more importantly, it's very limited validation-wise. So we currently lack robust real-world evidence for gait in patients with freezing. And that is actually where the Mobilize-D trial comes in. It's a multi-center cohort study which validated digital mobility outcomes in 5 different cohorts, including Parkinson's disease. And with this study, we aim to compare 24 technically validated DMOs in people with Parkinson's disease with and without freezing of gait and healthy controls during 1 week of free living data monitoring. The 24 DMOs were divided into 5 different gait categories, looking at the amount of walking or the quantity of walking, their pace, the pattern of their walking, their rhythm, and their variability. And the hypothesis was that it will be mainly the variability that will be different in freezers compared to the non-freezers. So this was a longitudinal observational study in which patients were measured every 6 months for 5 time points. We have Parkinson patients and healthy controls. People with Parkinson's were divided into a freezing and a non-freezing group using the new freezing of gait questionnaire. But since we know that NFOQ is not always super reliable for classifying patients, we also implemented a sensitivity group in which we only use consistent freezers and consistent no freezers, meaning that at every 5 time points of the longitudinal study, they answered the same on the new freezing of gate questionnaire. All participants first have a lab-based protocol followed by 7 days of free living gate monitoring using a lumbar wearable sensor. And when we look in the results, we first did an unpaired t-test to look at general differences in these 24 DMOs. And we found that freezers have a reduced pace domain, so slower speed, shorter step length, a lower stride duration, and also a higher cadence bout-to-bout variability. Afterwards, we corrected for disease severity since we really wanted to look into freezing-specific gait metrics. And here we found that patients with freezing have higher cadence bout-to-bout variability and a shorter stride duration compared to non-freezers. Also, in our sensitivity analysis with the consistent freezers and the consistent no freezers, the same patterns were shown, where the unpaired t-test showed differences in the pace domain, the cadence, and the stride duration. But after controlling for the disease severity, only the cadence variability and the stride duration was significantly different between the groups. There are some other DMOs that were different, but they did not survive correction for multiple comparisons. The last step was then to add our healthy controls, and we mainly found differences in DMOs between healthy controls and Parkinson's, as already shown in previous studies. But again, only the cadence variability and the stride duration were significantly different between those 3 groups, indicating that these are 2 very freezing-specific gait metrics. So we correlated them with the self-reported freezing severity. Stride duration showed no association with self-reported freezing. However, the cadence bout-to-bout variability did, indicating that a higher cadence bout-to-bout variability was also associated with higher self-reported freezing. So in conclusion, individuals with Parkinson's and freezing of gait show clear gait impairments even outside of their freezing episodes, indicating that freezing is not purely this episodic phenomenon we often see, but there are already some motor control deficits in their gait. These deficits were primarily linked to the rhythm and the variability, and we had 2 important DMOs. First of all, we found a shorter stride duration, which points out to an impairment in the temporal regulation of their gait. And this may reflect both an early breakdown before a freezing episode, where patients have like a faster hesitating gait with also some shorter step length. On the other hand, it can also just reflect an adaptive gait strategy, since the freezers in this cohort had clearly more gait and balance problems. Secondly, we saw that freezers had an increased bout-to-bout cadence variability, which indicates an unstable, noisy gait control, likely reflecting impairments in gait automaticity rather than adaptive flexibility, as often linked to healthy controls. There is a known link between dual tasking and an increased variability in the gait. So this made us think that this increased bout-to-bout variability could be further amplified by complex real-world environments, indicating that walking in daily life is a dual task for patients with freezing of gait. All of these differences were independent of the patient's disease severity. So taken together, these findings highlight that free living digital mobility outcomes provide a unique real-world insights beyond the clinical testing, supporting it to use it for further monitoring and personalized management in patients with freezing. And the future steps for this study will definitely be to see whether we can use these baseline digital mobility outcomes to predict whether a patient will develop freezing in the time course of this study. Additionally, future studies can also look into implementing turning into the digital mobility outcomes, since turning is the most common trigger for freezing of gait, and this was currently not implemented in this study design. And maybe look into combining gait detection algorithms with freezing detection algorithms to give us the opportunity to really look in the full picture of patients with freezing of gait. I want to acknowledge all the consortium partners within the Mobilize-D trial, and specifically, of course, the University of Leuven and my supervisors. And I thank you all for the attention and the Next Generation Symposium.
Thank you, Micah. Thank you. Great. Very interesting work. Let's see. I see. Okay, so York Nonakis is saying, fascinating work, Micah. Sorry, perhaps I missed it. Was stride time variability also a measure in your study?
Yeah, so within the variability domain, there were in total 4 different DMOs, and stride time was also one of them, but it did not show a difference. So it was only the cadence bout-to-bout variability that was significantly different in freezers versus non-freezers.
Gotcha. Good. And we hear from Simon Lewis, I might have missed it, but did non-freezers with higher variability in the real world have any objective fog when assessed in the lab?
Yeah, so that's definitely possible. However, in the non-freezers in this specific part of the study, we don't know whether they have objective freezing. The classification now was really made based on the new freezing of gate questionnaire. So we did not double check it with their lab-based assessment, whether we see objective freezing as well. But chances are very high that there are some unaware freezers in this non-freezing group.
I agree. Yeah, and I think you probably have the chance that maybe some of these, some of the non-freezers with increased stride time variability will transition later, right? I mean, that's a potential. I find that question very interesting because the a lot of these you noted potentially that there might be some changes in gait that are precede a fog episode but are not quite fog, which I think that would be argued by some as to whether or not those sort of abnormal steps should count as part of the fog episode. But to us, whenever we take these measures in our facility, I wonder whether kind of little subtle sub freezes are actually finding their way into the cadence and everything like that. So it is interesting to me to take these measures on somebody who doesn't have clear freezing yet and to see if it has predictive ability later. So very, very interesting work. How long is Mobilize D going? How long are you going to be able to follow these folks?
So in total, there were now 6 time points. And normally all the data collection of Mobilize D is finished.
Gotcha. Okay.
So all of at least the Parkinson's and the healthy control cohorts are all measured.
Wonderful. Okay, well, thank you, Micah. I appreciate that. Our next speaker is Lakshmi Pillai. She comes from the University of Arkansas.
Hello, everybody. I'm excited to be here today. So today my talk is about foot contact length and number of steps and how it can predict development of freezing of gait. Let me see if I can actually control this. So it looks like I can. So in terms of background, so we have shown previously that during continuous gait, freezers showed a faster decline in objective gait measures. And when we tried to categorize the accuracy, and we included gait parameters, levodopa, and cognitive decline and other parameters, but gait was one that showed better accuracy. And we also have seen that it is better to use the rate of decline that is over time that you see versus a single visit alone. And we've also shown previously that when compared to non-freezers, freezers had differences in some of the measures that we looked at, like shorter foot strike, increased foot strike variability, shorter stride length, and greater swing phase time. So we hypothesized that since turning is one of the most common times people freeze, what if we could use the spatiotemporal features of turning and see if they're important predictors for future phenotypic conversion from a non-freezer to a freezer, and to see which of these turn features could predict conversion to a fog phenotype over time. So that was the aim of the study. And so what we did was we followed non-freezers over time, so about 4 years. And so we requested our participants who are basically seen in the clinic to come in every 6 months if they could. And so not a perfect situation where we don't have all time points because COVID happened and then maybe somebody's sick, they're not able to come in with certain visits. So we do have gaps in data. And so what we did was they walk on the mat, and then at the ends they are turning. It's a 20 by 4 gait mat, photokinetics gait mat. And so people who remained non-freezers at their last monitored visits, they were classified as no fog. And those who developed freezing during this time were classified as fog converters. And then we would align the visits backwards. That is, for non-freezers, it would be the last monitored visits. And then for the freezers, the converters, it would be the closest 6-month intervals from the time of fog onset, the time of conversion. And I'm going to show you another slide to explain this better. And then after this, we calculated the ROC curve, like AOC values at each time point. And we used 13 spatio-temporal turn features, the means and the variation of those. And these spatio-temporal measures, we've been using the same measures over time because we've been doing turn analysis for Parkinson's patients. And so we have various publications on that. It's the same turn measures that we looked at here as well. So this is a figure representing the data collection and then how we realign the data for analysis. So if you look at the top figure where it says collected data, and we focus on the first line and the last line of that. So the blue represents from starting where they're non-freezers, and the orange is where they convert. So for example, the first line where you see that at 2.5 years, this participant converted to a freezer. And then the last line where the non-freezer over 5 years, they were followed and they did not convert at all. And so they remained as no fog. And so when we realign the data, the first line, if you look at it in the bottom figure, at 2.5 years, that visit becomes 0. And then we go backwards in time to see what changes happened. And so the initial visit becomes the 2.5 minus 2.5 year visit. And for the non-freezer, since they did not change, there was no fog conversion. So the 5-year visit becomes 0, and then it goes back in time every 6 months like that. So that is how we realign the data. So this is the demographics. So we followed 28 participants over time for about 4 years. And so 13 of them converted to freezers, and 15 remained non-freezers. And what I'm showing over here is at last visit for the non-freezer. So if they were there for 4 years, then the 4th year visit. For the converters, it was at the visit where they converted. So that is what we are showing over here, that particular visit demographics. And so between the non-freezers and the fog converters, there was not much difference in most of the variables that we looked at in terms of demographic categories. But the fog converters were marginally, at least they were slightly worse in their motor function and other things that we checked. What was significantly different was disease duration and PIGD score, where it is postural instability gait disorder, and that is a subset of the UPDRS score that we use. And that was interesting for us, but not a surprise because it has been shown that in freezers, PIGD score is something that is higher. And so this is what we have seen for demographics. Now, these are the 13 measures that we looked at, the mean and the variability of those. And so the first ones where the column 2 says PKMAS, so that is photokinetic software that we use for analysis. And so these terms were that is an standard output from PKMAS. And the ones that say Pillai et al. 2022, that is the one that we derived to analyze turn data that we collect. So those were the ones that we derived from the PKMAS measures. And so the highlighted ones represent the ones that are significant from our analysis, although we looked at all 13 of them. And so stance COP distance is something that usually reviewers also for our publications, they usually have some trouble with understanding that. And so I just want to explain that because the rest is kind of self-explanatory. So the stance COP distance takes into account also the pressure of center of pressure distance. So when somebody is in stance and then they keep their foot on the ground, and so the waveform trail, the center of pressure waveform trail is what it is, the distance of that. And so this is the ROC analysis result, where we have the AUC values at each time point. So 0, minus 0.5, like that, going up to minus 4 years. And so these are the 5 measures that were significant in terms of, this is a standard heat map using the colors that we use for representing, like red would be where the lowest, and then where it is going towards 1, which is a perfect score, where it is a binary classification where it is either non-freezer or a fog converter, what variables count towards that. And so green is better. And in this step count, turn time, and stride time, the variability in those were higher than 0.65 because that is the cutoff we used. 0.65 is what we used. Anything that is higher than, equal to or higher than that is what we considered as possible indicators for future conversion. And then stride velocity and stance COP distance, the means of those came up as significant for us as to higher than 0.65. The average, on the last line represent no fog and the fog converters, and the number of data points at each analysis standpoint that we have. And so, like, we could have gaps in data. And so, like, at minus 1.5 years, we only had 2 people who were able to come for the visit, was the fog converter group. And so there was that particular time point is possibly not the best indicator, but then 2 years, minus 2 years, you see that there are 9 people in each group. So that is good.
Okay, Lakshmi, so you're at time, so please maybe one more slide, okay?
Okay, thank you.
Oh, great.
And so in conclusion, we were able to show that the slower velocity, shorter foot contact, and greater variability in the number of steps and time taken to turn were the most consistent indicators of conversion to a fog phenotype when we checked over a 4-year period of conversion. And so we're grateful to the participants who gave their time and effort and for the funding source for my salary support. Thank you.
Well done. Great. Excellent. Thank you, Lakshmi. Let's see questions here. So no questions in the chat yet, but I did have a question, Lakshmi. Is this like a Cox proportional hazards design that you did, or I'm not sure. Could you clarify the analysis that you used for this? Time to event data, especially for really long time course things like Parkinson's, is quite tough. Can you talk about the analysis a little more?
Yes, actually, we did struggle with doing the time course analysis. So we did an ROC analysis, and so what we did was at each time point we ran this in SPSS, where we used the ROC analysis curve, and we actually said that okay, for the positive, like some 0 to 1, where the greater the number, like it took more close towards 1 would be the perfect scoring, where it would be more indicative of the converter phenotype. And so we had to tell that in the analysis that, use that, the higher numbers of, say, the number of steps that a person is using to turn. If that is on the higher side, then use that as an indicator that this person could be converting to the fog. So like that, for each variable, we had to assign based on what we have seen in the lab, like with our various studies that we have done for continuous gait as well as turn analysis. And so for each variable, we had to assign those numbers. And then as a positive or negative, basically, for the analysis. And then it would run the analysis and give us these AUC curve. Yes.
Gotcha. Neat. So and then you had, I assume you had some loss to follow up. Do you think that impacted this at all? Or, when you work with older people, sometimes you lose contact with them, it just.
Yes, but actually we do have some people lost to follow up, and then some people who come back, and so we have some gaps. But we have been really fortunate and grateful that people keep coming back. It's a lot of time and effort. So
Wonderful. Okay. Well, thank you so much. I appreciate that. And I think we can move on to our last speaker, Ravina. I think you're ready, and it's Ratnayaki. Am I doing that right? How would you pronounce your last name? Is that okay? Well, I'll let you do that. But Ravina comes to us from Arkansas State U, I believe. Is that correct?
I'm from UMS.
UMS, great. Okay.
Hi everyone, I'm Ravina Ratnaikar and I'm first year PhD student from UMS. And this is a pilot study where we wanted to look into seriometabolomic differences that are associated with freezing of gait in Parkinson's disease. So to give you a little bit of background of this research, so we all know that the Bragg hypothesis proposes that the PD pathology begins in the gut or the nasal cavity where the alpha-synuclein aggregation is triggered and gradually spreads to the central nervous system through the vagus nerve. So literature is coming out to show the gut microbiome alterations that are associated with the PD compared to healthy controls. So to actually relate those alterations to the pathological conditions that we see in the neurological conditions, especially in Alzheimer's and Parkinson's, we can use metabolites because some of these metabolites can cross the blood-brain barrier. So one of the examples is secondary bile acid. So if you look into the figure 1, that shows the bile acid as the mediators of the crosstalk between gut microbiome, liver, and the brain. So primary bile acids will be synthesized in the liver through cholesterol, and they will go to the intrahepatic circulation, and they will enter the gut for the further modification of by the gut microbiome produced enzymes to produce secondary bile acids. So then the secondary bile acids will go into the intrahepatic circulation and they will absorb to the liver. So part of the small percentage of the bile acids, secondary bile acids, will go to the systemic circulation and they will go interact with the bile acid receptors, which have anti-inflammation and neuroprotection effect. So what happens when the gut microbiota dysbiosis occurs is that these secondary bile acids go up high, which are often toxic, and the primary bile acids go down. So literature shows that the postmortem brain sample tissues and the serum samples of Alzheimer's patients have had low levels of primary bile acids and high levels of secondary bile acids. So that means that these secondary bile acids that have been produced in the gut have somehow have gone to the brain. So that means that the Bragg hypothesis, we can prove that. So so the impact is that since they are toxic, it can contribute to neuroinflammation and brain dysfunction. So since we saw that the lipids can act as precursors for bile acid synthesis, lipids are closely influenced by the gut microbiota and liver metabolism. So literature is showing that the metabolites involved in lipid metabolism, especially lower serum triglyceride levels, have been significantly associated with higher motor total scores, in specifically in 279 PD patients. So however, these relationships of these metabolite alterations, specifically with freezing of gait, remains unclear. So in this study, by using 29 PD patients, we want to answer this question as to are there any metabolomic signatures that are related to freezing of gait. So for this study, we recruited patients from the movement disorder clinic at UMS, and they were subjected for PD examination by the movement disorder clinician. And we also collected blood samples, and they were sent for the metabolomics analysis. And then we did the data analysis based on the clinical and metabolomics data. So we overall had a well-matched freezers and non-freezers, except for age and anxiety. So we had younger freezers, and they were more anxious. So that is also shown in the previous studies that there are differences in anxiety in terms of freezing of gait. And when it comes to metabolomics, we overall had 1,000 plus metabolites, but after quality control, we could only retain 878 metabolites. So we could see that primarily that the metabolites that were coming under lipid and energy metabolism pathways so significantly altered between the two groups. So if you see in the figure 2, in the top row, we saw lower levels of serum triglyceride levels in the patients who had freezing of gait, lower levels of creatinine, high levels of DOPA, and lower levels of glutathione. I want to specifically highlight this one because this is acyl carnitine, and that those levels were lower. So we also see this similar observation in patients who have Alzheimer's. They have also low serum levels of this, and this is showing that there's mitochondrial dysfunction, which is also a hallmark of most of the neurodegenerative diseases. And since we saw all those metabolite differences, we wanted to see the metabolite NFOG-Q relationship by using multivariate linear regression models by adjusting sex, BMI, and medication. So mainly we saw that lower LPI levels were associated with increased level of having freezing of gait. So the biological role of LPI is that it acts as a ligand for G protein coupled receptors, which exerts a neuroprotective role in Parkinson's disease. So since we saw all those differences, we wanted to see why not we could see into the pathways that were significantly altered in these patients. So for that, we used metaboanalyst software, but here we only could use 492 metabolites for this analysis because they only matched with the human metabolome database ID. So from this analysis, we saw that the TCA cycle was the one that significantly altered in the freezers compared to non-freezers. So overall, we saw that the metabolite differences between the people who had freezing of gait and those who did not. To further validate these results, we need a larger cohort, and that could represent a future potential target for preventing and treating freezing of gait. And finally, I would like to thank Dr. Tuhin Vermani and Lakshmi and all the participants who gave time and their blood samples for this study. And with that, I would like to take any questions that you have. Thank you.
Excellent. Thank you, Ravina. Very interesting. We have Moran Galat says, Ravina, very interesting work and thought-provoking. How variable are the metabolites on a day-to-day basis? Ooh, Moran, you were on something there. And can it be influenced by the stress of coming into the clinic on the day of testing, for example?
That's for sure. So this is a time point based analysis. So to answer that, we have to take this in a longitudinal, take as a longitudinal study, because of course when you tell them that we're going to take a blood sample, some people may be fear of needles, so that can cause anxiety. So for that, actually we need a longitudinal study to see actually these variables, like these metabolites, are actually affecting freezing of gait. But if you have here are several time points to see that, we can actually make a connection rather than just taking one time point to see that. I think it answered the question.
I think so. Did you so the time and day of testing, was that consistent across your freezer and non-freezer groups, or?
I think so, because I'm not the one who collected the data, but I think the patients came in several days. But this study was done in a particular period of time. So, but the patients did not come in one day, I think.
Gotcha. Okay. Yeah. I mean, so the time confound for metabolomics, yes. If all the freezers are after lunch, then you have a problem. Okay. So a question from Simon Lewis. Given that the motor features of Parkinson's can be confounded by concomitant cerebrovascular disease, have these patients undergone neuroimaging to determine their physicus ratings? That's from Simon Lewis. And I would tack on, it looked like you controlled for statins. Why?
Yes, because these patients are mostly on those medications for their cardiovascular diseases, because statins kind of alter the lipids levels in your blood. So that's why we use that medication specifically in our models to control that effect.
Interesting. Okay, so and then this have they undergone neuroimaging to determine their physicus ratings?
I cannot answer that question fully, but we do have imaging data, fMRI data, and EEG results from few patients, and right now I'm analyzing those results. But in future I can give an answer for that. I'm not specifically sure what means the physical ratings. I'm not familiar with that term. Sorry.
Me neither. That sounds like a doctor term. But so we can email Dr. Lewis about that. Jeff Hausdorff says, very interesting results. Can you speculate about the changes in metabolites that you observed and any specific mechanisms that might contribute to fog? So are you able to tie back your results to the bile hypothesis that you had going on?
So we did have bile acids in our panel, but we did not see any significant differences between the two groups. So that's why we actually need a larger group to actually validate those results. But we did see differences in the PD and healthy controls for sure, but we did not see that difference in the freezers and unfreezers.
Gotcha. Great. And Simon clarifies that the Physika score is a stroke rating, and so thank you, Dr. Lewis. I think that is time. So thank you, Ravina, so much. I have been, actually my colleague and mentor, Dr. Factor, was going to do this session, but he couldn't get out of clinic, so I got lucky and I got to proctor this very interesting session. So you cannot hear all of our applause presenters, but this was fascinating. So thank you all for taking the time to share your work with us. Thank you for doing that in a time zone that is amenable to all of us. Those are very difficult to find. And thank you especially to Kaylina Martins and her team for handling the abstract submission process. And I think this went off really well, and all of this stuff has been really great. Any other comments, Kaylina?
Thank you all for joining, and just a shout out to, we're all really looking forward to ICFOG in Nijmegen in 2028 in May, but I'm sure we'll host another NextGenFOG event in the meanwhile. So thank you all for joining, and yeah, really, really great panel of speakers.
Great. Okay. Well, I think with that, we can probably close, and thank you all, and we'll see you next time, okay? All right. Bye, everybody. Thank you.